Welcome back to another lecture, this time focused on replica sets and deployments. During our labs, we've really been deploying a single pod at a time. But you're probably thinking, hey, didn't you also tell us that containers can be restarted at any time when they complete successfully, encounter errors, or if the hosts have memory pressure? Shouldn't we be deploying these containers in groups so that they aren't all down at the same time? My answer is yep. You're right, and I'm glad you're paying close attention. This lesson, we'll discuss the answer to that, which are replica sets and deployments. As we've learned from previous lectures, we submit a request to the Kubernetes control plane to deploy pods. The internal controllers in the Kubernetes cluster spring into action and deploy our containers for us. Well, since we know we might want to deploy these pods in multiples, we can use a Kubernetes construct called a replica set. With a replica set, we again submit the request to the Kubernetes control plane. This time, a replica set controller jumps to action and creates the pod requests for us. These pod requests are then acted upon by the scheduler to deploy pods in groups for us. Let's see how a replica set manifest compares with the pod manifest we've recently learned about. First, let's review our pod manifest. I've taken the pod manifest from our previous lecture and added a section to the metadata fields. I've added labels, which are tags that help better describe our pods. These labels don't affect how the pod operates, but are often used to identify pods. Okay. Now let's take a look at a replica set manifest. Hopefully one of the first things you'll notice is that the specification of our pod manifest is included in our replica set. The replica set manifest kind of wraps our pod manifest with additional information. The replica set has its own metadata such as name and labels, just like a pod. But it also includes fields such as replicas, which, as you can guess, defines how many pods will be deployed, in this case 3, and it also includes a label selector. Notice that the match labels field shows app1. That means that any pods that have a label of app1, should be part of this replica set. This is important because if you add another pod to your Kubernetes cluster and it has the same label, the replica set will assume that the pod is part of the replica set, and it may adjust the total number of pods running to meet your replica count. Excellent. Now that you understand how replica sets work, I want you to know that you probably won't deploy these in your cluster. The reason is that we instead use a construct called a Kubernetes deployment. In the same way replica sets are created, deployments use a similar method. When you submit a deployment to the control plane, a deployment controller kicks into gear and it creates a replica set for us. And from there we know the replica set controller builds the pod spec, and the scheduler then deploys our pods for us. So why do we use deployments? Well, deployments specify more information about our pods, such as how they should be updated. For example, a deployment has a couple of deployment options. The first is recreate, where we take an existing set of containers and we delete them and build a new version. Maybe we're updating our app to a new version or a new container image. Doesn't really matter. Regardless, we replace those pods all at once. Deployments might more often use a strategy type of a rolling update, which takes our pods that are part of a deployment and slowly replaces them with a new version so that there isn't a downtime event where no pods are running. Rolling update deployments have a couple of additional options that allow us to tweak how many new pods will be created at a time, which is specified by the max surge property, and the number of pods that can be removed at one time, which is specified by the max unavailable property. The other function deployments give us is a way to roll back a deployment. If something bad happened with your deployment, you could have the Kubernetes cluster roll back your deployment to a previous state. Let's take a look at the difference between a deployment and a replica set manifest. Again, the replica set manifest is included within the deployment manifest. The deployment really wraps that replica set in new details. I will point out two sections that are added to the deployment. The first is an annotation. You can think of this as a note on an object. If we add an annotation of kubernetes.io/change-cause, we can enter a note about the deployment. This property gives the deployment a description so that if you decide to roll back later, you can see what the deployment was intended for. Assume you would update this field if you rolled out a new deployment so that if you had to roll back the deployment at a later time, you have a good description to help you. The second section is the strategy section, which describes how the Kubernetes pods should be updated. In this case, a rolling fashion, one at a time. In the next lecture, we'll go over interacting with deployments so you can see how we can use those with our Kubernetes cluster.